Algebra 1, Section 6.4. Today we're going to talk about compound inequalities. A compound inequality consists of two inequalities, either connected by the word and or connected by the word or. Let's look at two types of examples of compound inequalities. In example 1, part A says, write an inequality that represents all real numbers that are less than 0 or greater than 3. Let's look at the solution in part A and the graph. Here we have the two inequalities that are written. X is less than 0 or x is greater than 3. Notice what the graph looks like when we put that on the number line. I have one number line where the number line is shaded on the ends. Both ends are shaded and the arrows are shaded pointing out infinity in opposite directions. Part B says write an inequality that represents all numbers that are greater than or equal to -2 and less than 1. Notice that this compound inequality looks like one great big statement. And look how it's graphed. The graph shows two ends, one is closed and one is open, depending on the inequality. But the shading is in between the dots, not on the opposite ends of the dots, or the closed or the open circles. They are connected for an and. A compound inequality or graph looks like two separate graphs on one number line. A compound inequality and graph looks like one line segment on the number line. Let's do some examples on the next section. Here we go. Exercise for example 1. Number 1 for exercise example 1. X is greater than -4. Let's go ahead and write that. X is greater than -4 and less than or equal to -2. Okay, so I have this. Since I have the word and, these need to be combined as one statement. And I'm going to put these in order from least to greatest. So my x is going to be in between -4 and -2. Well, look at the inequality for x is greater than -4. Since I flipped that around to have the -4 down on the left end, the inequality needs to flip around. That's showing -4 is the smallest. X is greater than -4. And x is less than or equal to -2. So there's my compound inequality for number 1. How do I graph that? Well, let's go to the number line. Here's -4, there's -2, and there's 0. Now if you look at the inequality, if x is greater than -4, we have an open circle. When x is less than or equal to -2, we have a closed circle. If I have an and, everything in between is shaded. Number 2. Here's a new one. X is greater than 3 or less than -1. So I'm going to have x is greater than 3 or x is less than -1. When we have an or statement, the inequalities are separated. Okay, so in order, I have x is less than -1 and x is greater than 3. Look at how the inequalities are pointing. They're pointing on the opposite ends of each other. Let's go to the graph. I'm going to put a -1 here, 0, 1, 2, and 3. X is less than -1, so I have an open circle at -1, everything shaded left. And x is greater than 3. Open circle at 3, everything shaded to the right. Notice the difference what an or compound inequality looks like compared to an and compound inequality. Okay, let's look at the third one. All real numbers that are greater than 7 or less than 1. So I want x's that are greater than 7 or I want x's that are less than 1. So at 1, I'm going to have an open circle, and then at 7, I'm also going to have an open circle. I'm going to put a 1 here, And every other one is going to be by odds. That way I can go ahead and fit all of this on the number line. At 1, I have an open circle. Everything is shaded to the left. And where x is greater than 7, I have an open circle. Everything is shaded to the right. Notice again, this is an OR statement. So, for a compound inequality with AND in number 1, the inequality looks like one segment when it's graphed with 2 endpoints. When we have an OR, the inequality looks like 2 separate graphs on one number line pointing in opposite directions. Let's look at example 2. We're going to solve compound inequalities with AND. So I'm going to get one great big inequality. I have negative 9 is less than or equal to negative 4x minus 5, which is less than 3. What I want to do is isolate x. So basically I'm solving 2 problems simultaneously at once. So here I have negative 9 is less than or equal to negative 4x minus 5. And I'm going to undo a 2-step that's in the middle. So the first thing I'm going to do is add 5. And wherever I add 5, I add it to 3 places. I'm going to add it not only to both sides, to all 3 sides. So I get negative 4 is less than or equal to negative 4x is less than 8. Then in order to get x, I need to divide everything by negative 4. And whatever I do on one side, I do to all 3 sides. Since we're dividing by a negative, notice that all the inequalities flip around. Then I have to reverse my answer. I must have my answer from least to greatest like I would in a number line. So if I flip my answer around, the inequalities must also be flipped around. This is an AND inequality. The numbers or the solutions for x are in between negative 2 and positive 1. But since the inequality for the negative 2 is just a greater than for x, we have an open circle here at negative 2. X is also less than or equal to 1, so I have a closed circle at 1. Everything else in between is shaded. Let's go ahead and practice some of those. Let's solve the inequality for number 4. In the middle, I have 2x plus 1. So I have negative 3 is less than 2x plus 1 and less than or equal to 7. Let's solve for x. So I minus 1 on every side. Here I have negative 4 is less than 2x, which is less than or equal to 6. Now I want 2. So to undo multiplication of 2, I'm going to divide all sides by 2. Since I divided by positive, the inequalities stay the same. So I have a negative 2 is less than x and less than or equal to 3. Let's go to the number line. I'm going to put a negative 2 here. There's negative 1, 0, 1, 2, and then 3. At negative 2, I'd have an open circle. And at 3, I'd have a closed circle. Everything in between should be shaded. Let's do another one. Number 5, I want to isolate x. So how do I get rid of negative 3? I'm going to add 3 on all 3 sides. Negative 6 plus 3 is negative 3. That is less than x, which is less than negative 4. Is that in proper order? Yes, it is, because negative 3 is a lot smaller than negative 4. So let's go to the number line. I'm going to put a negative 3 here, a negative 1 here, and then a 1. So I've numbered every other one. At negative 3, I have an open circle, and at negative 1, I have an open circle. Everything in between gets shaded. Number 6, I would like for you to do on your own, and then you'll share that with your group. Let's move on to example 3. Now we're going to solve a compound inequality with an OR statement. This one is a little bit different. The OR statement means I'm going to have 2 inequalities separated from each other. They're not joined together like an AND. Notice in the work that the word OR is here. It separates 2 individual problems. Each problem is worked separately to get 2 different answers. Okay, and we're going to practice this. So when each problem is worked separately, I have two different inequalities. Notice that I still put them in order from least to greatest. So, I have x is less than negative 1, and I have to put this word or in my answer. That is going to be very important. And x is greater than or equal to 2. So, I graph these two separate answers on the same number line. Notice that the ends of the number line are shaded, including the arrow. They're pointed on the outside. Let's practice that one. Number 7. Solve the inequality and graph the solution. I have two separate inequalities separated by an or. So I'm really solving two separate problems at the same time. So I've added 3 here to both sides. 2x is less than 8. Divide everything by 2. X is less than 4. Or, in this one, I'm going to start with minusing 1 on both sides first. 3x is greater than or equal to 15. And then I divide both sides by 3. X is greater than or equal to 5. Is my answer in order from least to greatest? Yes, 4 is smaller than 5. So that answer goes on the left. Notice the inequalities, how they're pointing. They're both pointing to the outsides. So when I graph this, at 4, I'm going to have an open circle, and everything is shaded to the left, including the arrow. At 5, I'm going to have a closed circle. Everything is shaded to the right, including the arrow. Notice that in or statement, the two arrows are shaded. That is a little bit different than an and statement. What I'd like for you to do is number 8 on your own, and then you can compare it with the group. The last example, the real-life application. In 1985, a real estate property was sold for $145,000. The property was sold again in 1999 for $211,000. We want to write a compound inequality that represents the different values that the property was worth between 1985 and 1999. So I'm going to look at the values of 1985 through 1999. Since I'm looking at values between those, this is going to be considered an and statement. That means my inequality is going to be one big inequality, not two separate ones separated by an or. In 1985, the price was $145,000. And in 1999, the price was $211,000. So X is in between those. The smallest price was $145,000. So X was greater than or equal to that. And the largest price is $211,000. So X is less than or equal to that amount. Here I have my compound inequality. And this is an and compound inequality because the values include the smallest, the largest price, and any price in between. In 1990, that price had to have been between $145,000 and $211,000. Be sure you complete the other two problems on the previous examples in Example 2 and Example 3, and be ready to share and have questions the next time I see you in class.